Welcome back. Today we will be looking into developing hypothesis and understanding the possible conclusions. The objectives for this section are to understand and write a null and alternative hypothesis. So let's go ahead and jump right in. But wait a minute. Before I forget, I highly recommend you all to watch the previous videos so this video makes much more sense, all right? Because the terminology is very important. Now let's go ahead and jump in. So the first thing is to identify your null and your alternative. Remember what null hypothesis is. Null is no difference, everything is equal. So that's what null stands for. So when you see an equal to sign, that's your null hypothesis. And exactly the opposite of your null hypothesis is your alternative, which is not equal to, less than, or greater than. All right. So now, once we know what a null hypothesis is, how do I represent my null hypothesis? HO. Ho. Now, alternative hypothesis is HA. So it's like ho ha, right? Null and alternative. They complement one another because they are the opposites of one another. All right, let's take a look at the first example. A hospital claims that the mean wait time for emergency room patient is at least 55 minutes. A group of researchers believe that this is not accurate and want to show that the mean wait time is less than 55 minutes. They're asking you to identify the group's null hypothesis and alternative hypothesis. Now, I don't have to look deep for my null hypothesis because I know it's always equal to. I would always recommend to start with your alternative hypothesis. So let's go ahead and do that here. My alternative hypothesis, I'm going to start with my HA because I know my H naught is always mu equal to, right? Now, what do they say? I'm going to use my highlighter here. The researchers believe that this is not accurate and want to show that the wait time is less than 55. So the researchers want to show that the mu is less than 55. So once I know that, my null is always equal to 55. You see that? So what stays the same is mu stays the same. The number 55 stays the same, and the only thing that changes is the sign. So once you know this, let's go ahead and look for the options here. So definitely I'm going to start with my alternative. My alternative is mu less than 55. So not this, not this, not this. And I see that my only option here is, there you go. Fair enough. So mu less than 55 is my alternative. Mu equal to 55 is my null hypothesis. So when they ask you to identify your null and alternative, you always have to keep in mind your null is equal to. Your alternative is the one that changes based on your hypothesis. Now let's go ahead and take a look at the next one here. A car magazine claims that 68% of car owners follow a normal maintenance schedule. A mechanic does not think this is accurate, so he wants to show that the percentage of people who follow a normal maintenance schedule is not equal to 68%. So always when you are performing this hypothesis testing, I highly recommend or suggest to put yourself in that problem. So if you were a car mechanic, what would you do? They say it's equal to, but you think it's not equal to, right? So that's what you want to prove. So your alternative here is, remember, null is anything that's equal to is null. So I don't start with my null hypothesis. I start with my alternative. So here, let me see which one leads to my alternative. A mechanic does not think this is accurate, so he wants to show that the percentage of people who follow a normal maintenance schedule is not equal to 68. Do you see that? So it's not equal to 68. So my alternative here, I'm going to write HA. And here they're talking about percentage. So I'm going to use P, right? Is not equal to 68. I'm just going to say, yeah, 68%. Or because my options are in decimals, I'm going to change that to 0.68. 0.68. That is what the mechanic is thinking. So I have my alternative. Remember, blindly, your null hypothesis is equal to 0.68. So once you have these two, so I have my null, I have my alternative. Let's go ahead and pick the options. So definitely not this one, not equal to, yeah. Now definitely not greater than, definitely not equal to. So my only option is option 4, where the percentage is equal to 68 and the alternative is not equal to 68. Okay? And again, these problems require a little bit of patience and reading. I am able to do these because I've been doing these problems a lot. But when you are starting to do these problems, you will take time. So please, please, please make sure you read, comprehend, and put yourself in that situation to answer these problems better. Okay? All right, now let's go ahead and take a look. Which of the following results is a null hypothesis? P equal to 0.3 and alternative hypothesis not equal to. So the keywords here for not equal to is, let me put my leg up here. The keywords for not equal to is different. Definitely, oh God, this is moving. Okay. So definitely when it's less than, you use less than. When it's greater than, you use greater than. But different is not equal to. That's the keyword here. All right. So now let's go ahead and take a look. So I'm looking for something that says different because look at my alternative hypothesis. My alternative hypothesis is this. So I'm looking for the word different. Okay. All right. So let me read the first option. An insurance company claims that less than 30% of adults between the ages of 30 and 40 are overweight, and a group of doctors think this is not accurate and want to show that at least 30% of the adults are overweight. So in this particular option, they're talking about less than 30% and at least 30%. But look at your null hypothesis. One is equal to and one is not equal to. I did not talk about less than, greater than, or at least. So I know this is not my option. Let's look at the next one. An insurance company claims that more than 30% of the adults between the ages of 30 and 40 are overweight. A group of doctors think this is not accurate and want to show that at most. Again, they're talking about more than 30%, less than 30%, less than or equal to. In my problem, there is nothing like that. It's only equal to and not equal to. So again, this is not my option. Let's look at the next one. An insurance company claims that at least 30% of the adults between the ages of 30 and 40 are overweight. A group of doctors think this is not accurate and want to show that it's more than. That's not what the doctors are thinking. The doctors are saying our null hypothesis is equal to 30% and our alternative is different from 30%. We did not talk about less than or greater than. So again, this is not an option. Let's go ahead and read the last one. An insurance company claims that 30% of the adults between the ages of 30 and 40 are overweight. So you see that? They're claiming 30% are overweight. That means it's 30% equal to. A group of doctors think that this is not accurate and want to show that the percentage of these adults who are overweight is not 30%. So what they're saying is here they're claiming it is 30% and here the doctors want to show it's not 30%. So that means they want to show it's not 0.3 and here they want to show P equal to 0.3, which is our null and alternative. So in my null it says equal to, alternative it says not equal to. So you only look for those keywords. Let's do one more problem. All right, which of the following results in a null hypothesis? So my null hypothesis is equal to 0.48. look at my alternative. My alternative is greater than 0.48. So my keywords here is I'm looking for something that they want to prove it's greater than 0.48. So let's go ahead and look. See, in this particular problem, I don't even know what they're looking at. Just looking at my null and alternative, I know that they want to prove it's greater than 48% or 0.48. Let's go ahead. A car magazine claims that 48% of the car owners follow a normal maintenance. So they're claiming 48% of them. That means it's equal to 48. A mechanic thinks this is incorrect and wants to show that the percentage of car owners who follow a normal maintenance schedule is not 48. So here P is not 48. Okay, that's what I know. Let's look at the next one. The car magazine claims that at most of the cars, they're saying at most of the cars, owners follow a normal maintenance, and a mechanic thinks this is incorrect and wants to show that the percentage of car owners who follow a maintenance schedule is more than 48. So here he wants to show more than 0.48, but here it's at most. So my null hypothesis at most is less than or equal to 0.48. Keep in mind, I'm looking for the words equal to 0.48 and greater than 0.48. So I'm only going to pick the option that has those two. Let's look at the next option. A car magazine claims that at least, so when they say at least, it is greater than or equal to 0.48. Follow a normal maintenance, and a mechanic thinks this is incorrect and wants to show that the percentage of car owners who follow a normal maintenance is less than. So again, P is less than 0.48. So let's look at the next one. You see what I'm doing here? I'm writing my null, my alternative, null, alternative, null, alternative. A car magazine claims that more than 48% of the car owners follow a normal maintenance, so more than. And a mechanic thinks this is incorrect and wants to show that the percentage of car owners who follow a normal car maintenance schedule is at most. So this is less than or equal to at most. You might want to write this down. At least is greater than or equal to. At most is less than or equal to. Now looking at this, I am only trying to match my, I'm trying to match my null hypothesis and I'm trying to match my alternative. So let's go ahead and take a look here. Here it says, the first option says claims that 48% of the car owners. So P is 0.48. So if I look at this one, my null matches, but my alternative does not match. So this is not my option. In the second one, remember what I'm trying to look for. I'm trying to look for my null equal to. That means it should have an equal to symbol. Okay, so yes, this has an equal to symbol. What about my alternative? I'm looking at the second one. Alternative is greater than. Do you see that? Let's look at the third option here. This is greater than or equal to, and my alternative is less than. So this cannot be, this cannot be, this cannot be. So my only option here is option 2. Let me erase these so you can see it one more time. So in option 2, let me expand this, is at most. So my H naught is P at most is less than or equal to 0.48, and the maintenance schedule is more than 48%. So P is greater than 48%. So as you can see, my alternative matches and my null matches. Now you might ask, Miss, but the null does not have less than or equal to. Remember, as long as it has an equal to sign, that is my null hypothesis. So sometimes they will give you exactly equal to, or sometimes they will give it to you as at most, at least, where they include the equal to sign. Okay? All right. Let's go ahead and take a look at the next one. And again, this will be confusing in the beginning, but I highly recommend you all to take it slowly. Write down your null, write down your alternative, compare. Null, alternative. Remember, null is always equal to. That is basic equal to, or at least, or at most. So if I have these keywords, at least or at most, there is an equal to sign in them. So that automatically becomes my null hypothesis. Okay? All right. Distinguish between one and two-tailed. Remember when it's one and two-tailed. Remember when it's a right-tailed. Greater than is right-tailed. Less than is left-tailed. Not equal to is two-tailed. When I say it's not equal to, that means it could be less than or it could be greater than. Let's go ahead and take a look. So what tells you what tail test it is? You always look at your alternative. Remember, alternative hypothesis tells you what tail. Null does not tell you, only your alternative. So your alternative hypothesis will tell you. If your alternative is not equal to, that means it could be less than or it could be greater than. Fair enough? So it's a two-tailed. If your alternative is less than, that means it's left-tailed, as you can see here. If your alternative is greater than, it is your right-tailed. Okay, now let's go ahead and see if we can use this concept in the next two problems. Can I expand this? Okay, no. Yep, that's good. All right, identify the type of hypothesis test below. So here, when they say the type of hypothesis and the options are left, right, to, I'm not looking at my null hypothesis. I'm only looking at my alternative. So let me go ahead and highlight my alternative. And here you see my alternative is greater than. As you can see, it says x greater than 16.9. So when I say it's greater than, what tail does it? To the right. So this is my right-tailed test because greater than is always to your right-hand side. Okay? All right, now let's look at the next one. Is this test left, right, or two? Remember, I'm not looking at null hypothesis, so I'm simply going to cancel this one because this is always equal to. Look at your alternative. Not equal to. So when I say not equal to, that means I can be less than or I can be greater than. I could be greater than or I could be less than. It is two tails. Da, 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 da. So two-tailed hypothesis test. Again, quick recap. Your alternative is the only one that tells you if it is left, right, or two-tailed. All right.